Hey folks, Azure Cosmos DB TV. I'm Mark Brown, your host. Welcome. This episode we've got Kailan Modi. Kailan, how are you?
Pretty good. How are you, Mark?
I'm doing pretty good. In my brand new digs here. So I don't know if you know, we relocated from Southern California back to Seattle and then searched for a house for like 6 months. Not easy. But finally found a place and finally found an office. That was great. Working out of Microsoft campuses. Well, it's working out of Microsoft campus. We'll just put it that way.
Well, congratulations on a new place. Like, how are you liking it so far?
Nice being able to work from home again. It's the last time I worked from home was August. So yeah, that was a good 6 months of transitory living. But anyway, let's talk about MongoDB. Sorry, let me get it right. Azure Cosmos DB for MongoDB. And we're going to talk about specifically all of the vector search capabilities that we GA'd at Ignite back in November.
Yeah, I'm really excited to talk about this. This is something that I've been passionate about, and this is something that I think has changed the industry over a year and a half ago when ChatGPT was introduced. So I'm really looking forward to this presentation.
Yeah, I think I agree. I think this is an awesome set of features we've done in here. It was great, went over great at Ignite, and customers are loving it. So I'm glad we're, I don't know, this is an exciting time to be working on the product. So
exactly. I know you did a similar video on the Wheelie demo, and it has been a hit so far. People love the Wheelie demo. And I have a cousin to Wheelie today in my demo that I'll be showing at the end of this presentation.
So, oh, really? Wheelie's got family members?
Wheelie's got a family member, yeah. It's like a little brother.
I
don't have a photo for it yet. I don't have a logo, but that's coming. That's coming soon.
You know what? That's okay. It took me about 100 prompts with Dolly to get that logo right, or that avatar right. So just be patient.
I'll get there.
Yeah. Yeah. So what are you going to show us? Let's dive in. We got lots of stuff. I think you've got for us today.
Yeah. Let's dig in. So the agenda for this presentation is going to be, I'm going to talk about why Cosmos DB, Azure Cosmos DB. I'm going to go over a few concepts like vector search, vector embeddings, and vector indexing. Then I'm going to talk about the newest family member of our Cosmos DB family, which is the Azure Cosmos DB for MongoDB vCore that, as you said, we announced at Ignite of last year. Then I'm going to have a demo where I'll be showcasing our newest feature of vector search, where you can build an AI ad gen platform for your users and have multiple, with just one line of prompt, you can create your ads for multiple locations. And then in the end, I'm going to have the links up for people to take a look at and walk through the code and all that stuff. So as we all know, everything changed over a year and a half ago when OpenAI released ChatGPT. And this has probably changed the entire industry in pretty much record time. People are starting to realize what they can do with the data, which I think they never realized before. And we know these modern applications and intelligent workloads have unique requirements. They have data coming in, it's highly variable. It's coming in the form of images, streaming videos, audios, document files, telemetry from wearable devices and IoT devices, even Apple Watch or devices as well. And this has unpredictable traffic. And we know that users are distributed all over the world. And users expect the fast, always-on digital experience. This sounds like we might need multiple services, right? To store, vectorize, organize the data to build those AI applications. This is where our Azure databases come into play. Users can have one database for their operational or the transactional data, along with the vector data together. It's an all-in-one database, so you're going to save on cost and complexity. For example, if you're using a third-party single-purpose database like Pinecone, you'll have to ETL out of the transactional data stores and then put it in the database and surface that for vector queries and RAG patterns, and then bring the data back. However, this method has a lot of limitations, especially if your data is highly volatile. These third-party databases aren't best suited for such rapidly changing information because there's always going to be a lag in updating and querying the data. This delay means that the data you're analyzing is already outdated by the time it's ready to use. That's why I feel going with a first-party service is going to give you a better experience with real-time AI, it's going to be quite straightforward, and it's potentially going to cost you less. And in the end, it's going to give you the best integrations with other Azure services. What's they're not to like?
That's
So this,
right.
like Azure Cosmos DB is like the database for you to like try it out.
I agree. Simplicity is a key here, and
Mhm.
certainly cost, and not to mention kind of just technically, right? If you have highly volatile data, transactional data, that data belongs in a transaction database, right? Operational database. So, so if we can bring that to you in a database like that, then I think that's a winner.
Yeah, I agree.
Yeah.
Right. That's these are the basically the features I was talking about. It's an all-in-one solution. It's going to save cost and complexity, and it's going to give you the real-time AI. And we have like built-in vector search with our Azure Cosmos DB for MongoDB vCore, and also our Postgres SQL API. And soon we're going to have it for a NoSQL API in the coming months, where users can have like built-in vector search with their core NoSQL API. This is something that I'm really excited for and looking forward to it. Right. I know I use a lot of words like vector search, vector embeddings, and vector indexes. Users might be like confused what they actually mean. So let's dig into the concepts and to see what they mean and what this is. And this is going to help you and understand the demo that I'll be presenting in a few minutes. So let's start off by vector embeddings. So vector embedding is data in the form of like floating point numbers that like ML models and algorithms can easily use. It's a representation of the semantic meaning of a piece of text. So we look at these numbers and measure the distance between them. And if two texts are similar, then the vector representation should be similar or close by. So in simple terms, imagine you have a bunch of data, like like fruits. You have like apples, bananas, and all that different kinds of fruits. In the real world, you will be able to sort them based on the color or the taste or the size. But in the digital world, you can do something similar by converting the semantic meaning of the fruit into a list of numbers, which is usually called vectors. So we just take the semantic meaning of the word like apples and like convert that into a list of numbers, which is called vectors. And the interesting part is that the similar items will have similar vectors. By using vectors, we can use the math to understand and process them based on our needs. When we see two vectors that are close in meaning, then the vector representations are going to be similar or close by as well. And this is especially useful in like creating Gen AI applications like chatbot or like text generation or like searching text, documents, and recommendation systems, etc. Or even like searching for similar content. And I know in the previous back in the days, it was really difficult to build these like embeddings. But now with the APIs that we have, like the Azure OpenAI or the Hugging Face API, it's really easy to create embeddings for your data. And I'll be showing this in my demo as well, how easy it is to like create these embeddings and store it in your database. Okay, now we have the numbers, right? Okay, we have numbers. So we want to, how can we like search through them? This is where like vector search comes into play. Vector search is a method that helps you find like similar items based on their data characteristics rather than by the exact matches on a property field. So it works by taking the vector embeddings, the numbers of your data that you created by using a machine learning model, by using an embeddings API. Then it measures the distance between the data vector and the query vector. The query vector is the vector that you put into the question that you ask to the system. So it's going to measure the distance in the between the question that you ask and the information that you have in your database. The data vectors that are closest to your query vectors are the ones that are found to be the most similar semantically. And this is how it is able to give you the accurate answers. This is how ChatGPT works. So when you ask a question in ChatGPT, it's going to convert that question into a list of numbers. Then it's going to take that number, go to the database, search for it, and then come back and give you the most accurate response. Does that make sense?
Yeah, that's it's just amazing how just how powerful this is. I'm still always surprised, like what these types, this way of representing and searching for data is just. I mean, for me personally, it's so different than what I've been used to with doing things like equality or range filters. It's just this is not even in the same ballpark in terms of kind of how this technology works. And the fact that you can just generate these embeddings on any kind of text and then do this kind of semantic matching, this nearest neighbor with the semantic closeness, that's just kind of, I don't know, it's mind-blowing stuff to me.
It is mind-blowing. Yeah.
So,
yeah, especially like earlier when we used to like search something on the web, like we would go and search for like the keywords. And if you didn't get the keywords right, then you won't be able to get the answer that you're looking for. But now you can just put a random sentence and it will give you the accurate answer. So I feel like this is really mind-blowing. Like this is how far the technology has come, that we're just using like simple language that we use to speak to get the answer that we're looking for through the web.
Yep. Yeah, it's like a web search in a way, right? Like you've always been able, like Google or Bing or whatever, if you Google something with Bing, if you fat finger a search or whatever, it'll always come back with, did you mean this? Right. And of course, so they've always had kind of the ability to semantically understand what you're saying. And they're not using vectors necessarily to do that, but that's very similar in a way, right? But it's cleaner, obviously, in a something like a vector. But yeah, I'm always blown away, and I'm always surprised kind of the capabilities you can do. So
I think the reason it is cleaner is because we are able to index our data. So that's like when if you have our data index, then it knows where to look for. Earlier, like instead of going through all your database and like searching for the answer that you're looking for, we know where to look for, which is going to be like cheap and like very accurate. So this is where I want to go and like talk about the next concept that I have in mind for this vector search and vector indexing. This is where like we have vector indexing, vector indexes, which are being supported by Azure Cosmos DB. The first one we have the IVF and the HNSW. And it is very critical when building like these AI applications is to have the ability to index your data so that you can do like a semantic search that we're talking about and fetch the relevant data in order to make sure that you don't exceed your token limits. And like the good thing about Azure Cosmos DB is that these vector indexes are built right into the database. So you don't need like an external thing, or you don't need to go out and like come with it. So everything is right built into it. The first one we have is the IVF, which is the inverted file index. From my opinion, I think this is the most intuitive and straightforward vector indexing algorithm. It's basically a partitioning-based indexing group. So it works by clustering your vectors into groups based on the similarities to like certain central points. This significantly narrows down the search scope. And because instead of comparing your query vector against every vector in the database, it only goes and compares towards the same or the nearby cluster. So which is quite like fast, I feel like. And then we have the HNSW one, which is like a graph-based indexing algorithm. It involves by creating like a layered graph structure where each layer is a network of nodes connected in a way that allows for like efficient navigation and search. And the search begins at the top of the layer and then progressively moves down to the lower level, getting closer to the target. In most cases, I feel like HNSW is more robust than IVF. But the thing is, like HNSW is slower to build and uses more memory than IVF. So if you have a system that is like memory constrained and you don't foresee the need to rebuild your index often, then I feel like IVF is the way to go. Yeah.
Got it.
Yeah. So let's talk about a newest member of the Cosmos DB family, which I'm really excited to share about, is the Azure Cosmos DB for MongoDB vCore, which has a completely different form factor. It's based on the cluster form factor that allows to like scale up and scale outwards. So Azure Cosmos DB for MongoDB vCore, it is a fully managed MongoDB compatible database service for building modern applications with a familiar architecture. With Cosmos DB for MongoDB vCore, developers can enjoy the benefits of native Azure integrations, low total cost of ownership, and the familiar vCore architecture when migrating existing applications or even building new ones. We also have the free tier, which with 32 gigs of storage, which is like 64 times more than you'll find anywhere outside in the industry. We also have like burstable queues. We have new cluster tiers and storage queues based on your needs. And we also have support for private link and easy migration from MongoDB to MongoDB vCore. Additionally, vCore is AI ready. It includes native vector search along with IVF and HNSW indexing that I talked about. It is built into the engine. As I said, it's built into the engine. It is not built on a separate node. You don't have to pay extra or move your data. Therefore, your data, your embeddings, your vectors, and vector indexing is built into the database. Therefore, you can do your RAG patterns or like vector search efficiently. You can like learn more about it by visiting aka.ms/try vCore. Oh, one other thing that I want to talk about is we also provide plugins for like LangChain, semantic kernel, and llama index. So, and also we also have like easy integrations with Azure OpenAI Studio, which we have a really cool demo by Mark Brown. So I would really recommend you checking out the video that I think he should be linking up in this video somewhere. You should
Hey, if I'm not
check the
mistaken, we
video.
just announced the semantic caching, I think, with LangChain. Was that the one? I think I saw email floating around that, but I don't know. Maybe I'm making news here. I hope not.
No, I think no, it's not making news. We are actually making a blog post about it. So I think you guys should be subscribed to our channel or our social media, like LinkedIn or Twitter. We'll be having a blog post out, a video about it out as well, so you can get started and like learn more about the semantic kernel. Yeah, it's pretty cool.
The integrations are super important. I mean, everybody is exploring this space and building through these plugins, and having that connectivity to vector databases like Cosmos in our Mongo vCore option, and then others coming as well, and doing these things like the semantic cache, like just making sure that we've got the right connectivity for customers, meet them where they are with these plugins. I think it's important that we're doing this. I'm glad we're doing it, and customers seem to be loving it. So.
Yeah,
and the Azure OpenAI Studio integration as well, of course. Got to give a shout out to Wheelie.
Yeah, you got to shout out to Wheelie. Yeah. Right. So I'm gonna walk you through how the process works of like getting started with Azure Cosmos DB for MongoDB vCore. So I have a blog post out there. If you search through Azure Cosmos DB for MongoDB vCore GA, you should be able to find it. And we also have the link up for that in the description, or so you can take a look at it as well. So all you have to do is like scroll down to the bottom of the page and then click on Get Started Now. You can also use the link aka.ms/try vCore, TRY vCore. Once you are on this page, you want to go and click on Sign into Azure Portal. The good thing is we all have all the steps listed in this document. So I'm just gonna tell you the video implementation, but if you prefer like a step-by-step guide, you can always go to this website and take a look at it as well. So you want to click on Sign in to Azure Portal. And it's going to ask you for your authentication, your email and your password. I've already logged into it. And then you want to click on Azure Cosmos DB under Azure Resources. And then you want to click on Create and select Azure Cosmos DB for MongoDB. And as you can see, we have two different architectures. We have the request unit based, throughput based architecture, and then we have the vCore one that we recently announced. So we're going to click on vCore cluster. And you want to use your subscription and your resource group. I'll be using my resource group for the demo. And you want to give it a name, cluster name. I'm just going to go with KModi, and I'm going to enable the free tier. Obviously, if you don't want to start with the free tier, you can go into a configure and have multiple. We have like multiple cluster tier options that you can select through, and also we have like various like storage configurations for you as well. One also thing is you want to enable high availability. So what high availability basically means is in case your primary shard fails, we'll have like a standby shard ready for you to automatically take over. So you won't see a difference when your primary fails. Everything is going to work in the backend. So if something goes wrong, we will take care of you in the backend and make sure that everything works fine for your users or for your result. So you want to click with free tier and hit save, and then go back, select the Mongo version that you're looking for. We support like multiple Mongo versions, and then go ahead with the admin password and username. Then in the networking tab, this is very crucial. You don't want to give access to your MongoDB cluster to everyone. If you do want to give it to everyone, you can obviously add this symbol and give access to everyone. But right now, I'm just going to give it to my access to my IP address and hit review and create. And it's going to take around like 5 minutes to create the MongoDB cluster for you. For the sake of the presentation, I've already like deployed it. I have it ready, which I'll be using for the sake of for my presentation. So all you have to do is go to your connection string and then enter your username and password that you use to create this, and click on copy and take this and go to any emulator and then enter the connection string to get started. I have this vector search connection string that I've used, and then I'll be using this for my demo. So let's go back to our code and see how this whole thing works. So for this presentation, just imagine you are a shoe retailer who wants to sell more shoes. So you want to run advertisements to capitalize on recent trends, and you want to create like advertisement based on the inventory item that matches the trend. So instead of always like updating your advertisements, you just want to enter the advertisement or the location that you're looking for, and it's going to create the ad for you. So it's going to minimize the laborer's work of creating ads, recommending, like going through your database and searching for shoes that your customers are looking for. So for this setup, you will need an Azure OpenAI resource group, and we have the links. We have all the links in the aka.ms/adgen on how you can do this to get started. You'll also need a completions and the embeddings model, which again, we have the links for you on how you can get access to it. And then you will need to create an Azure Cosmos DB for MongoDB vCore resource, which I just talked about a few minutes ago. And then you will need to install the libraries, which I've already done for this presentation. Now, all you have to do in this code is go to your example.env file and just input your OpenAI OpenAI API keys and the endpoints and the versions, and you're ready to go. So I'm going to click on hit run. So it's going to take all my APIs and my endpoints from my example.env file, and it's going to load into my code. Now, I'm going to show you how to create an embedding, how easy it is to create an embedding right now. So I'll be using the text embedding ADA 002, which is the Azure OpenAI tool to create an embedding. I'm going to hit run, and it's going to create an embedding for shoes for San Francisco summer. And this is how the embedding is going to look like. It's basically a list of numbers or like vectors. And now I'm going to go and create and connect to my Cosmos DB for MongoDB vCore that I just created using the portal. So I'm going to hit run and get my connection string from my example.env file. And then I'm going to create a database and a collection. I'm going to create a database called adgen database and have a collection name as adgen collection. So I'm going to hit run. As you can see, it created a collection, adgen collection. So let's go back to my vector search database and see what we have. If I hit refresh, we have our adgen database and we have our collection right here. Now, let's go back and add some data to it. Okay. Before we add some data, let's also import the vector index that we'll be using for a demo. Right now, we have two different vector indexings that you can use. We have the IVF and HNSW. For the sake of this presentation, I'm going to use the IVF one because I feel like it's going to be fast and like we don't need to create indexing very often for this demo. So I'm going to hit run, and it's going to run and create that vector index in my database. And it's going to name it as vector search index. And then I'm going to upload my contents, upload my data to the collection, and I'm going to hit run. And it's going to upload around like 300 data points to my collection. Now let's go back to the collection, see what we have. As you can see, we have our data. We have around 262 kilobytes of storage size, and we have a lot of like data sets, which in the form of like the name of the shoe, the price, and the color, the brand name, as well as the purchase URL and the image URL. And also we have the content vectors inside our database. We have already generated the vector embeddings for our data, and we are going to store it in our database along with our along with our data set. Another thing I want to point out is we also have the indexes. We have the vector search index right here built into the database. So everything is right here. Everything is under one roof. You don't need, again, you don't need multiple services.
This is,
Isn't that cool?
I just want to kind of belabor the point here, but this is super important, right? Like if I'm going to insert or update data into my database, I can basically vectorize it and commit that as part of the same transaction. Like that's actually a good thing. Like your data is always going to be in sync if you write your application to kind of take advantage of the fact that these things can coexist within the same document within your database. So this is this is Mongo vCore. It doesn't have to be in the same document, but you can put it in a separate collection. But the fact is, you could make this as part of a committed transaction. Whereas if this was in some other database entirely, that's not possible, right? You're going to have some lag between the two. So. Yeah,
exactly. This is where I feel like you get the real-time experience, real-time AI analysis with Azure Cosmos DB from MongoDB vCore, because everything is right there under one umbrella. You don't need to like move and like go ahead. So it's really easy and really convenient for people who want to like develop and don't think about the database services.
Yep, that's right.
Yeah. So we have all the data sets right here. Let's go back to our Jupyter notebook and go ahead and start with the vector search. So we have our vector search function right here, which is going to take the vector embeddings of the query that we have, and it's going to come up with vector search. So let's hit run. And now let's perform vector search for shoes for Seattle weather, sweater weather, like the cold weather that it is. Like right now I'm in Seattle and I feel like it's quite chilly right now. So I want like shoes that are good for the Seattle sweater weather. And as you can see, it recommended me 3 different shoes. The first one is the rain boot shoes. I know Seattle is known to have rainy weather. It's most of the year we're gonna have the rain.
And the brochure,
yeah. So even though I didn't specify that it's gonna rain, it still recommended me the rain boot shoes as my first recommendation, which is quite fascinating. And then we have the second one is the waterproof hiking shoes. Seattle people are known to go on hikes any other weekends, and they need like those big chunky hiking boots. And then finally, you have the fashion boots. One good thing I want to point out is that it lists the similarity score. So based on the query that I entered in my application, it's going to match to see how close it is to the data set that's in my database, in my collection. So the first one is around like 83%, which is quite close because it's a winter rain boot shoes, which is perfect for Seattle. And it's going to give us the price as well as the image and the purchase link. So if you want to purchase this, you can just click on this link and take you to the website that you want to purchase, which is quite cool. Obviously, I have only 3 in my code, but obviously if you want more queries or if you want more recommendation, you can increase the number to 3 or 4 or 5 or whatever you're looking for. But for the sake of presentation, I have it at 3. But this is quite like, it's not very fascinating, right? It's not something that you would show it to your end users. You want to have like a website, or you want to have something cool that you can like display and like show it to people. So I'm gonna create an ad-gen content using ChatGPT-4, where I'm gonna give it a personality, call it Healy, which is Wheely's younger brother. He is like an intelligent assistant for generating witty and like captivating taglines for our online advertisement. The ad campaign tagline that it generates are like short and are typically under 100 characteristics. So I'm basically giving Healy a personality that I want you to create like a catchy, witty, and short sentences, like less than 100 characters for advertisement for selling shoes based on the topics that I say it to it. Again, we have a bunch of code. We also have the Dolly one. So if you want to create images for your advertisements, you can again do it. But I won't be going through the Dolly one right now. We'll just go through the basic website, and you can obviously work on it and make it even more engaging. So we have the HTML code, and we have a bunch of code, which basically is a way to like make it presentable to our users. So I'm going to go ahead and put everything together and hit run. So once you hit run, it's going to run on the local website, which we have here. And as you can see, this is where you enter the prompt for your Healy. So I'm going to say footwear for Seattle weather. And let's see what kind of shoes it's going to recommend me.
Okay, that number one's perfect for slopping around in the mud.
It is.
That's exactly what I need. I should get rid of the stupid fabric shoes I've got and get a pair of those things.
Yeah, this is why we need like vector search, because it's gonna take in other characteristics of the location that you're looking for and give you the recommendation which is most suitable. Instead of just giving you like a very generic one, it gives you very personalized recommendation. It's really good for creating advertisements for people. You can do something similar for a different location. Let's say we want to do it for Florida, where the weather is completely different from Seattle. I don't think you can even like compare the weather from Seattle to like Florida. Like, let's hit run and let's see what kind of recommendation it's going to give us. And I think it's going to be some kind of flip-flops. We do have flip-flops right here. The first, the ankle high sandals, and then we have the flip-flop sandals, and we have the tropical design loafers, which is again very Florida.
I think the first ones are maybe to protect against alligator bites or something. Maybe I don't know.
Yeah, I think so too.
It still rains in Florida, so you should still have rain boots, right? I mean, in fact, it probably rains more there than it does in Seattle. It just here it takes 10 months to get the same amount of rain there. They get in like an hour. So,
to be honest, yeah, in Seattle it doesn't rain that much, but it rains like throughout the year, but like it drizzles. Or in Florida, it like
rains. It's just basically spitting.
Basically, yeah.
It's an annoying drizzle. So
yeah. So this is really
cool. This is cool. I mean, it's definitely clearly adapting to what you're changing for the search within there, right? And coming up with things that are more appropriate. I've seen this over and over again when I do demos with kind of wheelie in there, and that's using the AdventureWorks data set, which is like a bike shop. And I'll make, I'll put in prompts in there like, hey, I want to go and hit some rugged trails and, plodding through the forest. And it comes back with mountain bikes. Like it knows how to associate that stuff together. And then without even providing any context at all, I'll say, hey, can you take that bike recommendation and give me some accessories I want to put on there? So I'm even more removed from providing any kind of useful input, but it can, if providing it some conversational history, it can look at that and say, oh, well, I told it to buy a mountain bike. I should give it accessories that make sense, because if you're going to be plodding through, forests around Microsoft or whatever, right? So it's just, I love that context that you can get, all centered around this vectorized data. It's really remarkable. Right? It's just fun stuff. So
yeah, having like RAG pattern applications is really fun, because like once you ask a question, it's going to store that question and the answer in the database. So it's going to remember that. So next time you ask a question, it's going to go back in history and see. It's like memory. Like, how someone like tells me, hey, I live in Seattle. So next time he talks to me, I know he lives in Seattle. So I'm going to talk to him about like Seattle weather and like location.
It'll remember that, provided the developer saves the chat history, right? So this is a thing I keep harping on is, hey man, these LLMs don't do it for you. If you just go, if ChatGPT did not store your chat history and you asked it questions like this, forget RAG pattern. You have no idea what you're talking about unless you provided that context, right? So if you want to have a conversation, you have to provide that conversational window and feed that back in. So important implementation detail for our RAG pattern friends. So
so remember, this is still a machine. Humans are different from machines, so you need to be very specific when working with a machine. You have to specify that you gotta store this instead of just assuming that it's going to do it for you.
We're not saying it won't hallucinate once in a while, because it certainly will, but if you don't do anything, it's going to come up with all kinds of stuff. So you got to give it some boundaries. So this is cool. Beautiful demo. I'm going to put up a link for this thing. This all runs out of a notebook. Is that right?
It does. And let me show you how exactly this thing works. Like, let's look at the architecture diagram. It's like quite simple. Like, it's not like very complicated. And the notebook, we have the link aka.ms/adgen. People can clone it and get started with it. You just need the connection strings, your endpoints for your OpenAI, and you can just run this. So how
That's
this will
cool.
work?
So connection strings, run a cell to load some data, and then basically run more cells to do what you just showed right here, right?
Yeah,
So,
it gives you all the explanation of what each block does. So it is a good experience. And the good thing about Jupyter Notebooks is we have like different cells, right? So it's basically like step 1, step 2. You're breaking it down into like smaller components. So you can like, instead of running the whole file, you can just like run each cell and get started with your journey, which is quite cool.
I will admit that I was not a huge fan of notebooks for a long time. I still find them kind of weird to be sitting in a notebook, but I'm slowly coming to the conclusion that they are really kind of fun little portable ways of writing and showing code versus like creating a console app. You can do you can just do lots of cool stuff. You can do visualizations. There's lots of cool little libraries you can throw into these things. Hell, you can even write them in C# if you wanted to. There's lots of capabilities. I think they're actually quite cool. I guess I'm coming around, and maybe I'm an old fuddy-duddy, and I and for me, notebooks is like what the data scientist guy uses all day long. It's sitting in Python versus like what an app dev is using. But I think they're actually pretty useful and handy. They're cool for doing little prototypes. They're just very useful. I'm just gonna.
They are very useful.
So
I used to think the same thing, that I used to think like Jupyter is known for like data scientists and not for like developers. But now once you start using it, once you get the hang of it, you just realize, you know what, this is what people are talking about. This is actually really cool.
right, and you just check into a GitHub repo. I mean, it's all just files and code. So yep.
All right,
cool.
Let's go. Let's see how the whole thing works. So we have our Azure Cosmos DB for MongoDB instance right here, which is going to store the data and is going to also store the vectors. But if you don't have the vectors, we have the vectorize function also, which you can like just call. We have it in the GitHub repo that you can use to call the vectorize function. So what the vectorize function basically does is it goes to the Azure it requests embeddings by calling the embeddings API from the Azure OpenAI, and it's gonna, once it gets the embedding, it's gonna store those vectors right into the database. So it's right there. Everything is right under one umbrella. And then we have the app service web UI, which is where you ask the question to Healy. So a user goes and asks a question to Healy, hey, give me footwear for Seattle. So now what it's going to do is it's going to go to the Azure OpenAI, again, a request for embeddings, get those embeddings, and then find the matching inventory in a database. Once it does find it, it's going to go and give you the output in the app service web UI, and it shows you the answer. It's quite straightforward. It's just like translating into numbers, then matching the numbers with the data set. Once it does find the numbers, what the dating set, it just translates the numbers to text and gives you the output. It's quite straightforward. But obviously, there's a lot of things that goes behind the scenes. But this is really something which I don't think I would imagine a couple of years ago, that it would be this easy to recommend or like build AI applications.
Agreed. It's getting more approachable. I mean, this is, it's not just Microsoft, but just in general. I think these are becoming more easier to understand and easier to build, and lots of tooling is coming along with it. So
now I have a surprise for our users watching this video. If you want to build these AI applications, and if you are customers of using Azure AI Service or GitHub Copilot, then you can get up to $6,000 worth of Azure Cosmos DB for free for 90 days. All you have to do is check out the link aka.ms/Azure AI Advantage blog. Just sign up for it. You can get up to like $6,000 worth of credits for free for 90 days. Get started, build your AI applications. And if you do build something, let us know in the comments so we can like take a look at it. So
just use if you're using Azure AI or GitHub in there, it's all you need to qualify, right? So if you're starting a new RAG pattern application, check out Cosmos. That will give you $6,000 of free Cosmos usage. And by the way, just want to point out, even if you're not using Mongo vCore, you should still be using Cosmos to store all your chat history in there. I don't know if people know this, but OpenAI uses Cosmos DB as the way it stores all of its chat history for ChatGPT. So anytime you go into ChatGPT app and you type in some prompts, and it gives you some responses and summarizes all that for you, and then you go away and come back, they're all still there. Those are all stored in Cosmos. There's lots of samples on how to use it in there. So anyway, you can use Mongo vCore for chat samples too, by the way, or chat history. But just want to point out. There's lots of reasons to use Cosmos if you're building these things, and it's $6,000 of free Cosmos. So take advantage.
Everyone wants free money, so everyone gets it's a win-win situation for everyone.
That's right.
Yeah.
Cool. So you got some more links here. You want to share? Oh, I wanted to share this one as well. So there's just some more rag pattern samples that we've produced. These are all Python, I'm guessing, right? All the rag pattern.
We do have it in Python, yeah.
Okay. Yep. So lots of samples for you on using Azure Cosmos DB for MongoDB. And using all our vector search capabilities right there within those Jupyter notebooks, and then links for all the other great stuff within there as well. So, hey, that's it. It's good having you, Kalan. Have you been on the show before? I think you have, right?
No, I don't think so, but this was the first time, and it was really fun.
Like, first time?
I was like, yeah, it's the first time.
Really? Are you sure?
Yeah, we've been like planning to do this for a while. And finally we got to this today, so I'm really like happy that I was able
all right
to
maybe all right.
Yeah.
All right, you know what, that's what it is. We've been trying to do this show since I think November, haven't we?
Yeah, we are.
And then holidays and just schedules and yeah, but I'm glad we finally got together. We got to do this show, so it's good having you on. You're absolutely going to be coming back later this spring, because we got a ton more stuff that's going to be coming out for all of our MongoDB, Azure Cosmos DB for MongoDB vCore. It's a mouthful getting it out there. So.
Yeah, I'm excited to share more features that we're working on right now. Like I think I'll be on the show very soon, so looking forward to it.
Looks good. Yeah, it'd be great to have you back. Well, thanks, Kalan, for joining us and showing us all the great stuff that we're doing around vector search and Azure Cosmos DB for MongoDB. And thank you, folks, for joining us as well. I know we're not getting as many shows out the door as we usually are. We're still trying to get things back in place. Me not living in like a cardboard box is part of that. Now that I've actually got a place and I can still try to get stuff set up, but I think we're finally on the right track. We're working on getting more shows together. We have lots of stuff to share with you and lots of stuff coming later at Build this year too. So we're only a few months away, and I'm just going to tease you a little bit. Not going to make any news, but you're definitely going to want to pay attention to what we've got coming. And we may sneak peek a few things here on the show as well. So, hey, that's it, folks. Thanks for joining us, and we'll see you again next time, okay? Bye-bye.